Friends, now we're going to meet Milad, get to know him in more detail and ask him some questions so that you can get an idea of what kind of specialists work at Aeronova. Milad, please tell us more about yourself so that people can get to know you better. Hello, Pavel. My name is Milad. If we talk about my past activities, I started programming and being interested in computers back in my youth. I have been in this domain since an early age. I work as a programmer. In the last decade, as you know, AI has become more and more interesting, so I decided to study artificial intelligence. So about 6 years ago, I came to Moscow and started studying at the Moscow Institute of Physics and Technology in artificial intelligence and computer science. Before that, I had a lot of experience in programming various electronic boards, microcontrollers, and so on. Now I try to apply artificial intelligence in microcontrollers to optimize algorithms for various tasks. I'm currently a graduate student at the Moscow Institute of Physics and Technology. Previously, I completed my master's degree at the same university. And recently, I found this interesting company, SOLARGROUP. Well, that is why I'm here, basically. SOLARGROUP has an interesting project related to airships. So I joined the company to participate in this project and started working on the airship control system. More specifically, we are designing and implementing all the elements of the control system, designing the boards, developing the logic, and implementing artificial intelligence in the operation of the various components and microcontrollers that are responsible for landing, detection, and other functions. My job specifically is to look for new methods to develop a reliable and advanced airship control system. Milad, I also know that you are a lecturer, that you teach at the university. Tell me a little bit about that. Right now, I'm finishing my PhD and working in parallel as a teaching assistant at the Moscow Institute of Physics and Technology. I teach artificial intelligence from a practical and theoretical viewpoint. Now there are a lot of foreign students in Russia who are starting to get interested in artificial intelligence, as this domain has become more and more popular in the last 10 years. But AI is not my only field of activity. I'm also very interested in working with microcontrollers, programming them, developing control system architecture for airplanes and airships. This is also a very interesting topic for me, and I have recently started working in this direction. We have already developed the concept of a control system for airships, but there is still a lot of work to do to create a larger, more advanced system. There are many engineers currently working on this system. I hope that in the future we'll be able to create an advanced airship control system. Milad, thank you very much for your answers. And I suggest we follow along, see what you are doing directly at Aeronova. Let's see. Can you please tell us what you do at Nova? There is an interesting scheme behind us. We have already said that it's a control system. Could you please tell us the details? What do you do? As you see, each block, well, I will now briefly explain the tasks of each block, each unit. When we talk about position in space, we mean the exact location of the airship. There are two aspects here: the airship on the ground and the airship in the air. When it is in the air, it is important for us to localize it and pinpoint its coordinates. This requires several sensors. One of them is the GPS sensor, which determines the exact location of the airship in real time. We also need an inertial measurement system unit, IMS, which I will talk more about later, what components and sensors go into it, and what they are used for. In addition, an external sensor is important. It serves as a wind sensor. It determines its direction, speed, and so on. As for the motion control unit, as I have said already, it controls the movement of the airship along different axes. Here we are talking about the airship's engine control system. We can control the altitude, which is the z-axis, and we can also control the flaps, which is the x-axis movement. So the airship moves in one direction or the other. As for the calculations, they fall into two categories: navigation and propulsion calculations. For each type, several microcontrollers are used, to which various sensors are connected to control and synchronize all the components. In terms of power supply, as I mentioned, we have a special system provided. I will talk more about it later. Now let's speak about one of the key parts of positioning, the inertial measurement system, IMS. The IMS measures and transmits data on the angular velocity and orientation of the airship. It includes several important sensors to accurately determine angular velocity and orientation, such as the gyroscope, magnetometer, accelerometer, barometric pressure and temperature sensor. As I mentioned, for this we use an internal pressure sensor that regulates the pump and the solenoid valve involved in controlling gaining the altitude. In addition, in the control system we also use flaps that are responsible for moving the airship along the x-axis, as well as angle of attack sensors that control movement in that direction. Then we have the computation units. And if we briefly explain the idea of computation in these navigation units, well, we use R microcontrollers for navigation computation, and actually it is not just one microcontroller but several of them operate simultaneously to manage all the tasks. We also plan to incorporate AI into the microcontrollers. It will serve as a predictive model for dynamic control and provide real-time anomaly detection, which is critical for safe landings. It is these two functions that serve as key application points for artificial intelligence in computing. In addition, we use cameras for visualization and object recognition. We use artificial intelligence in this area of computing too. We also have environmental and safety control systems, which are important for any airplane or airship in emergency situations. In the event of an emergency, there is the ability to land autonomously. Again, the ability to locate the airship is related to the safety issue. We also have emergency parachute opening systems, fire detection, and gas leak detection. It's all related to a safe environment. And you might have a question about how the communication between the ground and onboard system is organized. We use Mavlink, which is a very fast protocol for transferring data between microcontrollers. In the future, we plan to improve the communication system with additional protocols to allow not only mechanical, but also remote control of the airship via telecommunication terminals. Milad, do you understand correctly that this is just a piece of the whole circuit? And you have the main circuit here on a piece of paper. You have it more complete here. Absolutely. And right now, we're exploring that. We read a lot of articles almost every day about how to move towards the latest technologies, to understand the concepts that we are now discussing, and a lot of engineers are working on that now. Of course, in the future, we'll have far more complex and far more ambitious concepts. So that's the foundation. I've just explained to you the very basic principles. What's the next step? I mean, we have the circuits, the schemes. What do you plan to do with it? By the way, a great question. In the next step, my engineers and I were working every day to implement all those elements, the whole complex, the control system. We are programming the microcontrollers to interface with all the sensors to provide communication between them. And on top of that, we are working with onboard and ground-based telecommunications terminal systems to make sure that the airship communicates with each of these sensors.